Transferable skills is a buzzword around the job market nowadays. It just means you can apply what you learned in one area to someplace else. You too have some transferable skills because you learned the commutative and associative properties in matrices. You can quickly apply them in numbers. So, for the commutative property, I am showing the general form first. Can you read it for me? If you have followed the previous lesson, you can confidently explain that it says, the result of adding two numbers with different arrangements will give equal results. And this is true for all the numbers that are adding up, if they belong to real numbers. Great. For example, 2 and 3, they are real numbers. Add them like this or like this. You will get 5 either way. Thus, the addition of real numbers does not depend upon how you add it. But you knew that already, didn't you, my brilliant student? The associative property is a lot like the previous one. If you have to add 3 numbers, no matter what 2 numbers are added first, you will end up getting the same result. Take 5, 7 and 3. Add 5 and 7 first. Then add 3 to it. You get 15. Now, try adding 7 and 3 first. Then add 5 to this. 10. And you get 15 again. That's it. I told you at the very start. These properties are very obvious. Hold on. Did you think that commutative and associative were the only properties repeated from matrices? You're in for a surprise. We have the additive identity and the additive inverse coming right up. We have seen the additive and multiplicative identities in the chapter of matrices as well. Let me go over it really quickly. If you have 7 and I want you to add something to it so that we get 7 again, then what would that number be? Obviously, a big fat 0. So, this 0 is called the additive identity for this number 7 because under the operation of addition, it keeps the actual identity of a number. This is its general representation on your screen. It says for a real number a, adding 0 to it like this or this will give a again. That is, the identity of a remains unchanged. You know this one too, but let's quickly revise your concepts by taking 7 again. This time, add something to it that will result in additive identity. That is 0. Negative 7. Too obvious to tell, right? So, negative 7 will be called the additive inverse for 7. Similarly, the additive inverse of 3 will be negative 3. Or we can even say that for negative 3, the additive inverse is 3. Simple. To generalize this, we can say that for any real number a, we have its additive inverse negative a. And the addition of a number with its inverse either like this or this will result in a 0, which is the additive identity. That's it. We have discussed the properties of real numbers, but under addition only. There are many more to go. We will discuss them in the next session.